So now we're going to go over 9.2. 9.2 is with the converse of what we said yesterday, or I should say of lesson 9.1. So we had in it, if we had a parallelogram, we had 4 properties that we were looking at. We said opposite angles are congruent. We had opposite sides. We had consecutive angles are supplementary. And then we had the diagonals bisected each other. So we had these 4. Now, what we had was, we said if the shape was a parallelogram, so if parallelogram, then, and I'll just choose one of the properties, but all 4 opposite sides are congruent. Okay, so we had, if this was the case, then this. Now our converse is saying if, and we're going to switch it, opposite sides are congruent, then we have a parallelogram. So we're just working backwards on this from what we were doing yesterday. So what we want to do is check. So in question 1, we want to say, okay, if this is a parallelogram, then this side should equal this side. So we want to check that and see, does this side equal that side? So and then we want to say, okay, then this side needs to equal this side. So we're going to check it as we go through it. So you could check it one of 2 ways. I'll show you one way. So if this is the case, then when I plug in, so x is equal to y, and y equals 4. So that means 4 is equal to x, and 4 is equal to y. So we come in here and we plug in. So we go 5 times 4 minus 4. 5 times 4 is 20, minus 4, which is 16. So this side's 16. So I want to check, will I get 16 when I plug in here? So again, y is 4, so 2 times 4 plus 8. That's 8 plus 8, which is 16. So that's good. So now we want to check it here. So x should equal y, and y was 4. So we should have 4 plus 14. That's 18. And then we have, okay, now we should check it. 3 times 4 is 12. See how these don't match up? So these are not, so we'd say this quadrilateral is not a parallelogram. And we showed it because the opposite sides are not congruent. Okay, so we can come in here and we can do the same thing for this side. So we could say, okay, hey, this angle needs to equal this angle. We could do it that way. We could say that this angle and this angle are supplementary. They need to add to 180. But I'd be adding, and I'd have 2 different variables, z plus w. So I don't want to do that one. So I could just say, hey, those 2 need to be congruent. So these 2 need to be congruent. And these 2 need to be congruent. And it works out. I have w equal w. Okay, so I could plug in these values. I could plug in 4.5 and 11, but I want to show you a different way. We could also just write an equation. W plus 8 needs to equal 14w minus 1. And then we solve. So we subtract 12w. And then we would get 8 equals 2w minus 1. We'd add the 1 and get 9 equals 2w. Divide by 2. And so 4.5 equals w. Is that what we have? Yeah, okay, so we're good there. Now we want to check the z's and see if that works. So then we'd say 9z plus 19 equals 11z minus 3. So we subtract the 9z, and we get 2z plus 19 equals negative 3. Oh, I did it on the wrong side. So hold on, let me fix that real quick. So I should get here, 19 equals 2z minus 3. Add the 3, get 22 equals 2z. Divide by 2. And so, hey, 11 equals z. That's the way it should be. So we can say, yep, that's a parallelogram. Those opposite angles are congruent. So it'd be the same thing here. Okay, I need to show that these opposite sides are congruent. So I could say 7 times 2.4. So that would be 2.48. So it would be 8, 14, 16.8. And then I come in here and go 2.42 times 2.4 would be 4.8 plus 12. And that gives me 16.8. Hey, that side equals that side. That's good. So then these are consecutive angles, and consecutive angles should add to 180. So I plug it in. 9 times, or 10, there you go, times 9 minus 16. So that would be 90 minus 16. So that would be 74. And then I plug it in, 9 times 9, 9 times 9, plus 25. So that's 81 plus 25. So that would be 106. So does 74 plus 106. They add to 180, so that's good. So consecutive angles added to 180, opposite sides are congruent, so that is a parallelogram. Last one, again, we could do the same thing. We could set them equal. We could say 2x plus 2. This side needs to equal this side, 4x minus 10. I could do it that way and subtract the 2x and get 2x minus 10 equals positive 2. Add the 10. So 12 is equal to 2x. Divide by 2. So 6 is equal to x. So I could do it that way. Hey, that's what it should be. Or I could plug it in, 3.5. So 6 times 3.5 plus 1. So that would be 18, 21 plus 1 is 22. So this was 6 times 3 is 18. Half is 6. Yeah, so that's 21 plus 1 is 22. Then I could go in here and do the same thing. 8 times 3 is 24. So that's 28. Minus 6, hey, that's 22. And they're the same. So we showed that they're the same from there. So that's how you can go do it. So you could set up that equation and show that what x equals and y equals, what your variable equals, or you could plug it in and solve it that way.